Hey, hi guys. In this today session, I will only discuss the interview perspective L2 L3 forwarding because most of the questions, most of the interviews, especially when I take the interview for any engineers, I especially ask this kind of questions. So let's go through that scenario. So basically, ACI does have four types of scenario. So what happened when source and destination uh, address present in the same leaf, how the leaf will work. So first thing answer is leaf will no, if the source and destination both are in the same local leaf tightly connected, leaf will not send packet to the any spine and leaf switches. Okay, it will automatically locally do the ARP lookup or L3 lookup. Second scenario is what if source leaf know the destination about the remote switches. What if source address present in a one switch and destination is in different switch? How the packet forwarding will work? That we call that remote endpoint. Okay. If the traffic is known, it will do the unicast communication. If traffic is unknown, it will do the uh, flooding or hardware proxy communication based on your this domain setting. Third scenario is source leaf doesn't have the information about the destination, which is the sprint proxy will do that. If your L3 traffic is unknown, L2 traffic is unknown, how the traffic will work. Suppose you are trying to ping from one source to another source, and you don't know the destination. How the spine can play the role of the proxy on behalf of the destination. Fourth scenario is source leaf doesn't have know the information about the source leaf doesn't have the information about the destination host, but this packet is L2. Okay, this is all the L3, this is L3, this is L2 traffic. How the L2 traffic will work here? Okay, if this domain is L2, this all the encapsulation. This if the packet is remote, packet will send to the leaf will add the VXL header, then it forward the to destination based on the tap address IP. Then it will, the moment tap will receive the destination switch will receive that packet, it will decapsulate the VXL, it will send to the endpoints. It's a straightforward uh, kind of traffic. If traffic is like a spine proxy, the moment your leaf will receive the packet, it will go send your packet to the spine switch Unicast. This is again tap address. It can be your route effector IP or RP IP, randomized point IP, and leaf switch will also add the VXLAN header and the forwarding based on the outer IP address. Leaf switch will always forward your packet based on the outer IP address. As a source, it will use a tap address, and destination will also use the tap address, whether it can be this tap or this tap. So for the hardware proxy cases, destination will be this tap address. Okay, and the lookup will be happen based on the MAC address and IP address, and then packet will forward to the leaf will do the decapsulation. So basically there is ingress and egress leaf. Okay, ingress leaf will always receive the will be the source. Egress means always will be packet who will receive the packet, destination switch. Okay, and all the traffic works within the ACI. If someone asks what is the multicast attack trees in ACI, how the load balancing works is in ACI, what kind of mechanism it used in ACI. So answer is we ACI use multicast FTAG tree, which is by default is created. You do not need to create that. So FTAG value is just like you assume it's a fabric path kind of stuff, right? In fabric path, if you have heard about the FTAG values, fabric tag values or forwarding tag values. So forwarding tag values we will enable kind of multi-path, multi-destination traffic load balancing in the ACI. Suppose your host is sitting in one switch, for example, this one. Host is sitting one switch and destination is sitting in another switch. So how many paths you have to reach the destination? You have two paths by default. Tab one can reach to the spine one, it can to the spine two. These switches, both switches has the information about the tab three. So it can forward one packet to here to here. Second packet can be here to here to here. It can be load balanced, and this is by default like nature. So in the topology, you will see that we have the four tag value. You can see that every leaf switch in the fabric is connected to the each if f tag values, and so there is a like root f tag for each spine switches. Okay, so for S1, for here, suppose we have four f tag value. For f tag, if I show you, so let me take that snip to explain you better. So suppose you have f tag this one, S1 f tag. So for S1 f tag, root f tag value 1, 2, 3, 4. So for one f tag, these switches will be followers, this will be leader. For f tag 2, this switch spine switch will be the leader and these will be the followers. For f tag 3, spine 3 will be leader and these will be the followers. For f tag 4, spine 4 will be leader, these will be the followers. So this way it can maintain the proper database, as well as it can give you the better performance in the load balancing of the fabric. Okay, so third question is how the ACI L2 non-unicast works. Okay, how the L2 unicast traffic works. You have L2 traffic. So first thing is when you try to ping from H1 to S2, they are in two different leaf, but they are in the same bridge domain. They are in same bridge domain, but can be different VLAN or same VLAN. Okay, but in two different EPGs, same VRF. Okay, how the traffic will work? Traffic will first initiate from host to the gateway, which is the leaf one is the gateway. L1 represents here leaf 1, L2, L3, L3, L means leaf here. So L1 will, the moment leaf 1 will receive the packet, it will do the L2 lookup based on the destination MAC address. Right? Find that destination MAC address belongs to this particular leaf, tab 3, right? Because it's a non-unicast, so source leaf switches will already have the information about the destination. Then packet will forward to the spine switch will receive the packet, and the spine switch will not do any kind of encapsulation decapsulation based on that L3 routing lookup, destination IP lookup. It will check that okay, this particular tab belongs to this one, this destination, leaf 3. Packet will forward to the leaf 3. Leaf 3 will also do the L2 lookup, then it will forward your packet to the uh, bridge of this particular bridge domain and install in the local database if it is not present. If it is present, that's fine. Then packet will forward to the leaf 2, leaf 3. So this like this encapsulation will happen here. Source address will be tab address of the leaf source. Destination address will be this one in an outer. So there is a two types of VXLAN header, outer, here will be inner. In the inner IP address, this will be the host IP address. In outer IP address, there's going to be tap address. Tap address are the source and destination leaf. And encapsulation will be happen here. Decapsulation will be happen here. Okay. Fourth question is how the L3 unicast traffic works. This is the L2 unicast traffic, right? Your traffic is L2 and how the L3 unicast traffic works. And the scenario is same. We have uh, two different EPGs, bridge domain, and two different EPGs in the same VRF. Previously, the EPG was two different, but bridge domain was same. It means they were in the same subnet. You can say that. And here we have two different subnets. How the L3 traffic will work here? Okay, so let's take example. So when you have L3 traffic here, first will traffic will hit to the leaf source leaf. Instead of L2 lookup, this switch will do the L3 lookup. Okay, in the L3 lookup, it will check the destination IP and find the endpoint with the destination of this one. So it based on the routing table, this leaf switch has already know that tap address and this particular EPG information from this particular tap address. So leaf 1 will have like tab 6 belong to the EPG 3, which we are trying to ping. right? And this switch has the information by tab 1. I have H1 information, and this is the S3 information, EPG1 information. So all the encapsulation will happen here. Then packet will forward to the spine switch. Spine switch will receive the frame. It will check the outer destination address. In the outer destination address, it will check the tap address. Okay, spine will not care about the what is your endpoint source and destination. It will check the tap address, and based on the tap address, it will say that okay, this is that belong this tap belongs to the leaf 6. Packet will forward to the leaf switch. Then leaf switch will do the L3 lookup based on the uh, destination IP. It will check the routing in a VRF label, and it will hit in the local database and drive destination to the send destination to the send the particular destination to the EPG3. Okay. Fifth question is how the L3 spine proxy works. Okay, how the L3 spine proxy works is, suppose you have source and destination present in a two different or even the same base domain. Okay, and traffic is unknown unicast. You can say that unknown unicast is we call that. How L3 unknown unicast works in ACI. So we have in this domain, if I try to log in, you somewhere, I think empty cloud. I have already lab which I can. I have session somewhere here. Let it put. Okay, so we'll check that later. So in a biz domain, we have L2 and L3 option. Okay, in biz domain we have L2 L3 option. So in that biz domain, you when you select that flood L2 unknown unicast, it means traffic will be unknown unicast will be flooding the entire fabric. If you select that L2 forwarding as a hardware proxy, that will be only valid for the L3 traffic. Suppose you're trying to ping here to here. Okay, suppose you have 10.1.1.1, you're trying to ping like 20.1.1 or 10.1. Same subnet or different subnet, doesn't matter for here. First packet will send as a ARP request when you try to ping from initiate the ping from here, and this suppose this H1 doesn't have the destination information, it will always do the ARP lookup. It will do the ARP flood forwarding. ARP means address resolution protocol, which will be the IP to MAC address lookup. IP to MAC. You know the IP address, but you don't know the MAC address. In this case, what will happen? Traffic will on the leaf 1, traffic will do the lookup. If the H2 traffic is not learned on the leaf 1, it will send to the spine proxy device based on the spine tap address, unicast tap address. Based if you have hardware proxy enabled, okay, then spine switch doesn't. If so, spine switch, what will it will say that okay, no worries, let me do the ARP gleaning. ARP gleaning means it will send the ARP request to entire directly connected leaf switches. Okay, the moment packet will receive, spine switch will say okay, H2 information, this source information, even I don't have it. If it has the information, no problem, spine will reply to the leaf switch. If spine doesn't have the information, spine switch will say okay, I'm going to do broadcast, which is ARP gleaning in ACI. Whoever has this particular host information, please reply with that. Just like the legacy network. So in this case, all the 4 packets is coming here. So once the packet will receive, the right host will reply to the spine switch. Okay, with the multicast address. GeoIP address. And once the reply will come, then source and destination will be installed in the table. This is the normal lookup happen. So this is the like let me show that how the what kind of uh, ACI proxy, how many types of ACI proxy we have. Okay, and I will talk like forwarding mode of the bridge domain and how unicast traffic works, how if you enable the multi-destination flood and bridge domain level, how traffic will behave. That may cover in the next session. So there are three types of proxy happen on the spine switches. First is a proxy anycast MAC address. So if you have unknown unicast packet as a L2, L2 unknown unicast mode is hardware proxy for the L2 traffic. If you have traffic with the IPv4 and R flooding is mode is off. Okay, and third is of course for IPv6. Okay, this we call that art gain silent post tracking. If unicast packet hitting on the, if you say that this one, so let me take check a look like that. If packet is hitting here, spine switch will have the proxy unicast. And if spine proxy will work if you do not have the art gleaning, and spine proxy will work if you do not have the entry in the kube table. Okay, and if art gleaning is not enabled, then packet will be dropped. If the packet spine will forward your packet to the all the directly connected leaf. If reply is unknown something, then packet will be dropped. If reply is coming from the appropriate host, then this particular entry will reply, your spines which will reply to the source destination. Okay, there are a lot of things like the line card label forwarding, EPM table, HAL table, all the things works. And like forwarding, a lot of things are there in ACI. How ICMP works, how ARP requests work. So this is just a normal Lexi. If you know the Lexi infrastructure, how ARP works in ACI. So when any kind of endpoints is connected right here, how the first time they discover to the directly connected devices, they will send the ARP request, okay, to the leaf will learn the source and destination MAC address. Leaf will do the same entry in the kube database which is present on a spine switches, and leaf will reply to your uh, packet. This happen for the bridge domain level. Okay, yep, this is what I wanted to cover, and there are a lot of questions and lot of things which needs to be covered for the knowledge purpose. So there are like multiple VLAN types in ACI which happen, and we can ask, someone can ask you like how many types of VLAN encapsulation happen in ACI, right? So what is the VLAN ID? What is the hardware VLAN? What is the access encapsulation type? What the meaning of access encapsulation? What is the meaning of fabric encapsulation? What is the meaning of BD VLAN? Because if you see that, so system internal EPM, even you will see that there are a lot of VLANs. You will configure VLAN 10. On behind the VLAN 10, you will see that the 6 to 8 VLAN, right? So what is the VLAN ID? The platform independent which you assign as in the points. Okay, this will be the your actual VLAN. What is the hardware VID? VLAN ID used for the by the hardware for the VLAN translation. So this is the internal ACI used VLAN. Okay, you do not have control over it. Okay, and type there is like bridge domain control infrastructure VLAN, which is will be used by the tab. There is a VD external VLAN which will be used for the external communication. BD VLAN, bridge domain VLAN can be mapped with a single or encapsulated multiple VLAN, and there is a FD VLAN used for the EPG encapsulation. Okay, FD means it's a VXLAN kind of. Okay. What is the fabric encapsulation? So it's a VXLAN used inside the fabric. When you see the fabric encapsulation ID, the fabric encapsulation ID will be this one, VXLAN ID. If you see the fabric encapsulation type of fabric encapsulation will be used within the inside. So all the fabric encapsulation will be within the inside for the ACI programming. Okay. Access encapsulation will be used for the EPG communication. For the EPG communication. If you see that these are the how the mapping works. If you have the two leaf one, leaf two. Okay. So there is like access VLAN ID for the external device communication. When you have any host connected to it, it will use the access VLAN. Then hardware will use this access VLAN convert into the PI VLAN. Okay, that PI VLAN is still again is a hardware VLAN for internal programming. Then you have the VXLAN VNID, which will be the forwarding within the fabric, which will be used for the within the fabric forwarding. Then you have the bridge domain ID. Then when you configure that EPG, when you have EPG ID here again. So there are multiple types of VLAN which being used in ACI. And yeah, this is the what we can take a look. And next question is let's talk about the bounce entry. What is the bounce entry? Okay. The remote endpoint created by the COOP when EP moves. Suppose you have one EP here, endpoint sitting in leaf one, and that endpoint move to the leaf three for some reason, for some migration purpose. In this case, ACI create the bounce entry. We call that stale entry also. Okay. So when you see the stale entry, so there is a multiple option to it. So your spine switch needs to be updated. If spine switch does not update that movement, EP movement from one leaf to another leaf, in this case, stale entry will be created. And that means you will gonna have issue with the traffic forwarding. Okay. What is the COOP table? What is the purpose of it? So when leaf doesn't know the destination IP address or destination endpoints, leaf can forward packet to the spine switch in order to let the spine take the decision on behalf of you. We call that spine proxy or proxy table. Normally, spine does not push the COOP table entities to the EF leaf. It just receives from the leaf uh, data management engine, actually. Okay. Remote endpoint are stored on the each leaf as a cache. This not reported to the spine switches. So make sure that when leaf is sending any endpoint details to the COOP table, leaf will only send the local learn endpoint detail. In the table, in the leaf table, you will see remote endpoint, local endpoint, right? Only leaf update the local endpoint to the COOP table. It will not update the uh, remote endpoint. And yeah, this is the all. Little bit about the privacy gateway. What is the privacy gateway? It's a default gateway for the endpoints, nothing else. And what is the bridge domain? Bridge domain is a L2, L3 boundary for the bridge domain for the network. Only bridge domain is the one who will decide whether traffic is L2 or L3. How the privacy gateway is deployed? It will be installed on the it will install as a SBI on the switches. So if you see that there was like this VLAN, right? BDSBI. So when you create the bridge domain, it will create as a SBI. It will use internal ID. It will use the internal VLAN ID and VXLAN ID. You will not have the visibility of it by default until you want to troubleshoot it in hardware level. So that entry will be created as a SBI here. So the moment you will see that so bridge domain or so IP route, you will see that privacy is written there. That means that is the bridge domain IP address. and you will see that one VLAN will be tagged along with that. Um, this is all, and we'll see you in next session where we are going to talk more about the access policy and tenant communication, how the access policy and tenant communication works, which is very important in order to deploy the infrastructure. And the last, not the least question is contract. So contract, what is the contract? We have multiple types of contract. Okay, so in ACI, how many type of contract we have? First, we have standard contract. Second, we have ABGNE. We have contract. Then we have interface contract. Okay. Standard contract means uh, in EPG to EPG communication when you want to do. When you have ABGNE, it means this communication will be any to any communication. It will be applied under the VRF label. This will be applied one-to-one communication will be applied EPG label. Okay, taboo contact. This will be to stop or block all the traffic. Yes, if you have the import traffic, it will block all the import traffic in your wherever you applied that in the switch. Intercontact contact means when you have inter tenant communication. Suppose you are applying, uh, you are creating, establishing the communication between tenant one to tenant two. You have to export that communicate contact from one tenant to another tenant. We call that interface contact. We call that, and this will be applied under the EPG label. And suppose you have one leaf. This is a very hypothetical questions. And suppose you have one EPG. Okay. Let's take example. You have EPG1, EPG2. This is very good questions. EPG2. And you have three types of contract. Standard, for example, where is that? So I'm going to apply all three contract here between two EPGs. Which contract will be preferred over the, which contract will take the preference? Okay. So there is a precedence, there is a contact preference in the ACI. So let me show that. ACI contract priority. I will say security configuration. No. If I go here, here must be the preference for the contract. How ACI contract if do have somewhere seen that contract. Ah, yeah, I think this is the one. There must be preference. You will see that here priority. So the moment you will see that contract, so joining, you will see that priority table, right? In this priority, the lowest priority will be preferred over the highest one. So there is a priority. Yeah, this is a priority, which I was talking about. Like this is the intra contact. You see, if the priority is one, so this is the in your uh, kind of a standard contact, which will be always priority one. EPG to EPG, 7 to 9 priority. So lowest priority will be always win. So if you have these three contact, okay, standard contact is more to specific to EPG to EPG. ABGN is global contact kind of, okay, and which will take priority 17 to 20. And we have taboo contact, which again will have different kind of priority. And then we have intercommunication. So first priority will take the extended contact. More specific, just like the routing. Suppose you have slash 32, you have routing slash 24. Which one will take preferred? Highest prefix list will take preference, right? Similar way in ACI we have this priority. So we have priority 7 and 9. We have 17, then 19, I think, for ABGNE, 70 to 20. These are the priority which will be there. So always EPG to standard contact will take preference over the EPG to any if you have ABGNE contact or anything. Suppose you want to overrule any contact which is already there. So for example, uh, this contact, this particular contact already there, ABGNE, and you want to overrule that contact. Okay, you do not want to expose your endpoints. What you can do, you can just create the standard contact and map EPG to EPG. Do not take the control VRF label. Then this will be absolute excluded and this will be added in the joining. Okay, this is the very good document which you can refer for the contact preference contact priority, because while designing the network you must understand that what exactly is happening, how the contact is working, because if you do not have the understanding the contract, how contact works in ACI, then you're gonna have you will suffer a lot, to be honest. Okay, how you check that? You just check the sojourning. Sojourning means so contact, so ACL, just like that. So you will see that implicit, what is the filter ID, and here you will see the preference. So if you have deny and you have permit, if you have deny for the same traffic with the preference number 21 or 17, you have permit is 7, it means permit 7 will be preferred over this one, deny one. Okay, so if it is joining same permit, so deny logs will know. This is again, you must read this document, which is very important actually, and this can give you a very good perspective of the priority. So there is flag values priority. If you have contact which specify the TCP flags, it will give the priority 1. If you have specified this protocol, it will go for the uh, priority 2. If you specify any source, any specific destination, it will go for priority 1. So each and everything has priority here. How the ACI take decision in your infrastructure, how contract works. Suppose you are creating the contract, right? In this contract, you are giving the source and destination. Both you are specifying for T port number 80, port number 80. In this, the preference will be this one. If you are specifying any to any, priority will be 1. if it's specifying the protocol any to a specific protocol, source is any to a specific port or protocol, this will be the priority 3. If you specify any port to any destination, so suppose you have specified the TCP to any protocol, any port 80 to any port, it will be this priority. If we have source and destination port any to any, it will take preference is 5. So this is always recommended to have that chain. Okay. Uh, you can also manipulate that lowest priority and highest priority default label for the contract. When you're applying the contract, you have option under the contract. You can just specify that under the filter. So which priority level you want to choose that. By default will be the default one. And default this configuration set to deny the role with the same priority as one of the permit. If you have the lowest priority, means this configuration set to deny a rule at the same level a which any rule. If you have medium, this configuration deny a rule priority corresponding to EPG to any. If you have a highest priority, this configuration set the priority to evaluate EPG to EPG contract. So it's again, so whatever its default is there, just keep that until unless you have some specific deployment requirement. Okay. So as a taboo contract has priority 5, which is higher than regular contract. Okay, taboo contracts configure security again is same under the same tab, and taboo contract will be uh, highest priority if you are deploying. So what I was talking about here is it has 7 standard contract has 7 priority and 9, and it has 17 or 20, but taboo has 5 priority. It means if you are applying 3 contract and the EPG, taboo will be the preferred one. If you are applying these two, then standard contract will be preferred one. And there is directional also. If you are deploying unidirectional, bidirectional contract for ingress, egress both, you can check from the output itself how you are applying the traffic source, whether you're applying this under the filter, you have to specify that what is the source and destination. And if I show you that how to configure it, if I may, just give me a second, let me show you that how to do that. Yeah, so I do have the lab access now, so I can go here and view this lab and I can log in. This is the Cisco D Cloud lab I have. So you can book this lab. If I go, let me show that how contact we can create, how we can check the zoning and all the things. So I do have this epic. So whatever I have, I was talking about it. I will show that how bridge domain works here and where you can get that so zoning information. If I go here and if I type here so zoning zone, it might not come because it has to be a leaf label, leaf and spine label, but for it's not coming. But anyways, we will see that UI label. And so here we have. So if I go to tenant and under the bridge domain, let's take common tenant. If I go to any random bridge domain, a default one, let's take a default bridge domain under the policy. Under the policy, you will see that multiple types. So whatever I was talking about L2 unknown traffic, flood and hardware proxy. Hardware proxy is recommended when you have L3 unicast is enabled, and flood is recommended when you have traffic is L2. Bridge domain is L2, and make sure this traffic should be. Just give me a second. Let me minimize this page. It's very big. Yeah. So this one, and make sure that when you enabling the hardware proxy, you must have the unicast enabled. No, it's not mandatory, but it's recommended to have it. And when you have the flooding, when you enable the L2 flooding, you just disable the unknown unicast routing and set all the like R flooding and the unknown unicast flooding is enabled. Okay, and you can say optimize R, but doesn't make sense. And this is the one, and the contact. This is the contact tab we have here. Here you have multiple standard contact, taboo contact. Under the standard contact, you can create ABZNE. Okay, so here we have the filter, where R filter, default filter, which I was talking about it. If I go and create one standard contact, create like VRF, for example, scope can be VRF. Within the VRF, I'm going to create subject. I can create subject. I apply unidirectional, bidirectional. Unidirectional means source will be able to ping, destination will not be able to ping. But bidirectional means apply the both direction, source and destination. And the filter I can create separately, or I can create from here. I can use R filter, which is common, and I can permit, and default priority is here, or else I can create the new con. Here is not showing, that's fine. I can create it later. Submit. This is the contact I created one. So let me create one filter, show you that how the contact filter works. If you have filter, have entities, if I create a TCP and ether, you can specify. I'm going to create for IP address filtering and specify the protocol. Of course, I'm going to specify TCP. These are the protocol which you can filter. I'm specifying that port like HTTP and HTTP, or else you can just type that port 80, port 80, port 80, port 80. Just update it. This is the filter. Same filter you can call under the this contact. So if I create here a contact test, if I want to create global contact means intertenant or something, I can use that. I'm going to use call this, like I was showing that I created filter. If you want priority, you can change the priority. Okay, but you do not want to change, that's up to you how you want to create. Here is the priority. While creating the filter, there must be option. Let's go to the contact or test, and the VRF. I go to the policy. There is a like keywords policies also which you can apply for the contact. What kind of traffic you want to allow and deny. Peer entity don't have anything. Nowhere else is applied. And if I double click on this, and if I try to change anything, you have to change under the filter, or else you just keep that as it is. And you can apply, there is multiple ways. There is a VRF label contact, which let me go to the VRF here, policy. There is a contact which I can apply. So if I try to go to any of the, sorry, this EPG, this is the ABG any contract. Here you can apply that ABG any contract. Here they have EPG collection. This is the contract which we call that ABG any. I can call that contact which whatever I have created test in a source, provider, and consumer. It means any EPG can talk to any EPG here. Okay, if you have a ABG, this one, so you can set the label provider consumer, and if you want to create a specific standard contact, you go under the EPG. You might not have any EPG. Under the EPG, you can let me create one EPG like test. Default I'm going to use. This is application profile, create EPG, test one. Oh, I created wrong thing. Okay, so here we have contact option. We'll see that contact. So under the EPG, you can create that. So this contract, EPG able contract will always override the ABG any contract. But all the contract will be overridden by the taboo contract, which is here, taboo contract. Taboo contract. This is all about the how the contract works and EPG works here scenario. Thanks for watching. We'll try to record next session for something else.